Okay, we're now going to move into area problems. And here we have a rectangle. And I'm going to assume that the blue on the inside is the original rectangle. And this rectangle is going to increase in area. So a rectangle is 3 times as long as it is wide. So I'm going to let the small side be W, and I'll claim the length as 3W, 3 times as long as it is wide. Okay, this rectangle increases in length by 6. So up here I'll say I'm growing in length by 6 and in width by 8. So I have some dimension of the longer that matches up with the smaller. So this is a W, and then this is 3W. And then the problem tells me that the area increases by 108. So in green, I'm going to shade in what represents the 108 square units of area growth. Read the problem, mark up your sketch, understand what's happening, and now the next thing to do, let's represent the entire area of the large region. So the entire dimension of width would be W, the original blue W, plus the 8 increased. And then the entire length is now 3W from the original rectangle, plus the additional 6, representing the length of the larger. The next thing to do, set up a verbal model to represent what's happening. And you have choices for doing this. I'm going to go with something simple like the small area plus the 108 increased growth units. That equals the larger new rectangle. And just keep the words simple so that you really do understand what's happening. And now come behind, as always, and slip in the algebra. So the interior, the blue, smaller, original rectangle, its area would be W times 3W, or 3W squared. So that would represent the small area, plus the 108, the number that you're given in the problem. And then the large new area that it's represented in red in words, just simply take the dimensions in red and set up your binomial multiplication. And now we need to solve for W. And as promised, the squared terms or the quadratic terms for now, they will have the same coefficient. You're just simply left with solving something this simple. So in wrapping up to answer the problem, the dimensions of the original rectangle, well, the original is a 2 by 6. The increased large is a 10 by 12. And you can verify the areas. The area of the small rectangle would be 12. So the area of the small would be 12 square units. The area of the large will be 120 units squared. And the difference between those two numbers would be the 108 in red. So with problems like these, you always have a way to check yourself. I'm going to set up the second problem a little bit for you and ask you to finish it on your own. So I have a rectangle that's twice as long as it is wide. If its length is decreased by 4 and width decreased by 2, the area is decreased by 24. So just for the purposes of this, just understanding so that we're all actually doing the same problem, let's assume that we're starting with a large rectangle and it's losing area. So mark your sketch up so that the larger rectangle is where we're starting. And now we're taking away area. So length is decreased by 4 and width is decreased by 2. So the length comes down by 4 So that means the blue 2W loses 4, and then the blue W loses 2. The area is decreased by 24, so I'll represent that with green. And you could set this up in several ways. You could say that the large original minus 24 equals the new smaller rectangle. And I'm going to stop here and let you use the other example to see if you can set this up and solve. And then we'll talk about this in class.